Hey, cosmic explorers, future astronauts, and curious minds, welcome back to Cosmic Enigma, your portal to the universe's most fascinating secrets. Tonight, let's turn our gaze to our closest celestial neighbor, the Moon. You know its familiar face, the stark craters, the dark, ancient seas. But what if there's a bizarre, beautiful secret painted right on its surface? A mystery that challenges our understanding of lunar geology and promises incredible insights for future space exploration. Not shadows, not mountains, but something far more enigmatic: lunar swirls. Imagine brushstrokes of light across the moon's dusty canvas. That's precisely what lunar swirls appear to be. These bright, winding features look like abstract art, defying the moon's otherwise rugged, cratered terrain. The most famous example, Reiner Gamma, is so prominent you can even spot it with a backyard telescope, a testament to its striking visual contrast. Yet here's the profound puzzle. These aren't elevated features casting shadows, nor are they depressions. They exist purely as variations in surface brightness, like a cosmic tattoo etched onto the lunar regolith. These aren't just pretty patterns, they are geological anomalies. Unlike typical lunar features formed by impacts or volcanic activity, swirls seem to float on the surface. Their bright, sinuous forms often meander across craters and plains alike, suggesting a formation mechanism independent of underlying topography. This visual peculiarity immediately signals to scientists that something truly unique is at play, inviting us to look beyond the obvious and delve into the moon's hidden processes. To truly appreciate the mystery of lunar swirls, we must first understand the moon's harsh environment. Unlike Earth, our moon lacks a global magnetic field. This means it has no protective shield against the sun's relentless assault. The solar wind, a constant stream of high-energy charged particles, bombards the lunar surface without impediment. Over eons, this bombardment causes space weathering, a process that darkens the lunar regolith, turning it from bright, fresh material into a mature, darker hue. This continuous cosmic erosion is a fundamental process shaping airless bodies throughout our solar system. It alters the optical properties, chemical composition, and even the physical structure of the surface. For lunar researchers, understanding space weathering is crucial for interpreting remote sensing data and planning future missions. It's the baseline against which the anomaly of lunar swirls truly stands out, making their bright, unweathered appearance even more perplexing and scientifically significant. Here's where the plot thickens and the mystery deepens for science students and lunar researchers alike. Every single lunar swirl we found is sitting directly over a strong, localized magnetic field. It's like finding a permanent magnet on a non-magnetic fridge, or a tiny, invisible umbrella shielding a specific spot from a constant downpour. These mini-magnetospheres are strong enough to deflect the solar wind, creating a localized bubble of protection. This magnetic anomaly is the core of the enigma. How did these isolated magnetic fields form on a body that otherwise lacks a global magnetic dynamo? And why do they correlate so perfectly with these bright, unweathered surface features? This direct link between surface appearance and subsurface magnetism is a profound clue, suggesting a fundamental interaction between the moon's interior, its ancient history, and the space environment. It's a puzzle that promises to unlock secrets about planetary evolution. Scientists have been debating the origins of lunar swirls for decades, and the theories are as captivating as the swirls themselves. Each hypothesis offers a unique perspective, pushing the boundaries of our understanding of lunar processes. These aren't just academic exercises. They are speculative journeys into the moon's past and present, guiding future research and exploration. One of the most popular and compelling ideas is the cosmic sunscreen. Imagine these localized magnetic fields acting like invisible umbrellas, shielding the surface beneath them from the solar wind's darkening effects. Without the constant sunburn from solar particles, the swirl areas remain bright and optically immature, retaining their original, fresher appearance. Meanwhile, the unprotected surrounding areas continue to darken through space weathering. It's a permanent cosmic sunscreen, preserving patches of the moon's original brightness. This theory is particularly appealing to future astronauts and space enthusiasts because it implies a natural radiation shield. If these mini-magnetospheres can deflect solar wind particles, could they also offer some protection against more harmful solar energetic particles, SEPs, or even galactic cosmic rays, GCRs? This speculative possibility makes lunar swirls potential prime locations for future human habitats, offering a naturally safer environment on an otherwise exposed lunar surface. Another intriguing theory, the cometary scouring pad, proposes a more violent origin. What if a comet, rather than a typical asteroid, slammed into the moon? This theory suggests that the comet's turbulent gas and dust, rich in volatiles, could have scoured the surface upon impact. This scouring action might have exposed fresh, bright material from beneath the weathered regolith. Crucially, the impact itself, or the unique composition of the cometary material, could have generated or influenced the localized magnetic fields observed today. This hypothesis connects the swirls to the moon's impact history, a dominant force in its evolution. It speculates on the unique effects of cometary impacts versus asteroidal ones, potentially revealing new insights into the types of objects that have struck the moon over billions of years. For lunar researchers, this theory opens avenues for studying impact mechanics and the subsequent geological and magnetic responses of planetary bodies. Then there's the electrostatic dust dance, a super cool and subtle mechanism. This theory posits that weak electric fields created by the interaction of the magnetic anomalies with the solar wind plasma could actually lift and sort fine charged dust particles on the surface. These electrostatic forces could then arrange the dust into the bright, swirling patterns we observe. It's a dynamic process where the magnetic field subtly manipulates the lunar regolith itself. This theory highlights the complex interplay of forces on airless bodies, where even seemingly weak electrostatic charges can have significant effects on surface morphology. For science students, it's a fantastic example of how fundamental physics principles manifest on a planetary scale. Understanding this dust dance is also vital for future lunar operations, as electrostatic dust can be a major challenge for equipment and human health on the moon. A newer and increasingly compelling idea, hidden underground magnets, suggests that these localized magnetic fields originate from ancient, unseen magma flows deep beneath the surface. The moon once had a global magnetic field, much like Earth's, though it has long since dissipated. As this ancient lava cooled slowly in the presence of the moon's early magnetic field, it could have magnetized the rocks, creating geological magnets that are now buried. These deep-seated magnetic anomalies then influence the surface above, creating the conditions for the swirls. This theory delves into the moon's paleomagnetic history, offering clues about its internal structure and the evolution of its core. For lunar researchers, it provides a window into a time when the moon was geologically more active and possessed a dynamo. It suggests that the swirls are not just surface phenomena, but are direct manifestations of deep lunar history preserved for billions of years. The truth is, scientists are still working on it. It's likely a complex interplay of several factors, perhaps even a combination of these theories. But why do these lunar swirls matter so profoundly? They are far more than just pretty patterns. They are incredible natural laboratories, offering unparalleled opportunities for scientific discovery and future human endeavors. Lunar swirls help us understand fundamental processes in space. They are unique testbeds for studying how magnetic fields work in the vacuum of space, how surfaces weather without an atmosphere, and the intricate interactions between solar wind and planetary bodies. By comparing the bright, unweathered swirl regions with the darker, weathered surrounding areas, scientists can precisely quantify the effects of space weathering, providing crucial data for understanding other airless bodies like Mercury or asteroids. Furthermore, these localized magnetic anomalies offer invaluable insights into the moon's ancient magnetic history. They are fossilized remnants of a past lunar dynamo, providing clues about the moon's internal structure, its thermal evolution, and the processes that once generated a global magnetic field. Understanding the moon's magnetic past helps us piece together the broader story of planetary formation and evolution in our solar system. Here's the truly exciting part for future astronauts and space enthusiasts. If these mini-magnetospheres offer radiation protection, lunar swirls could be prime locations for future human habitats on the moon. Imagine a lunar base naturally shielded from some of the harshest radiation in space. This could significantly reduce the engineering challenges and health risks associated with long-duration lunar missions, making sustained human presence more feasible. Beyond radiation shielding, these unique environments might also hold hidden water resources or other valuable volatiles. The magnetic fields could potentially trap or concentrate certain particles, leading to localized deposits. While speculative, the possibility of finding unique mineral compositions or even preserved ice beneath these shielded regions makes them incredibly attractive targets for resource prospecting. Lunar swirls could become the strategic outposts of humanity's future on the moon, offering both safety and resources. The scientific community is not just speculating. We are actively pursuing answers. NASA's Lunar Vertex mission is planning to send a rover to the Reiner Gamma area in 2025. This will be a monumental step forward, marking the first time we get direct in situ surface measurements of a lunar swirl. The rover will carry instruments to measure magnetic fields, analyze the composition of the regolith, and study the interaction of the solar wind with the surface. This mission is a game-changer for lunar research. It promises to provide definitive answers to long-standing questions about swirl formation, space weathering, and lunar magnetism. For science students, it's a live example of how scientific hypotheses are tested through direct exploration. The data from Lunar Vertex will not only unravel the mystery of swirls, but also inform future lunar missions, paving the way for sustainable human presence and deeper scientific understanding of our cosmic neighbor. The moon continues to surprise us with its enduring mysteries. Lunar swirls are a beautiful reminder that there's always more to discover right in our cosmic backyard, even on a body we've studied for centuries. They challenge our assumptions, ignite our curiosity, and inspire us to push the boundaries of exploration. These bright, enigmatic patterns are not just geological curiosities. They are beacons guiding us towards a deeper understanding of planetary processes and potential future homes for humanity. What do you think causes these incredible patterns? Are they cosmic sunscreens, ancient scars, or something else entirely? The journey of discovery is ongoing, and your curiosity is a vital part of it. Join the conversation, share your theories, and stay tuned as we continue to unravel the moon's secrets. Don't miss out on the next cosmic revelation. Hit that subscribe button, ring the notification bell, and share this video with fellow space enthusiasts, science students, and future astronauts. Let's explore the universe together.